All right, we'll go through some questions picked from tutorial sheets and just pay attention. We'll be very fast. We'll leave some questions just for the sake of you guys to practice. So, shall we start? Okay, so the question says evaluate the function at each specified value of independent variable and simplify. So what you're going to do is we have a function here and they're telling us to say, so we do this like this. So this is a, right? So the function is fx is equal to root of x plus 7 like that, then plus 2 outside. So what we do is this is the function. They are now saying this is when we put x there, this is what we get. But now they are saying for number one, they are saying now f of what? Negative 5. So we'll put wherever this x, we'll put negative 5. So what we'll do is we'll put negative 5 there plus 7, then plus 2 outside there. So what we are going to have is root 2. I mean, inside there we'll have 7 minus negative 5 plus 7, that will be 2, then plus 2. All right. Can we go in further? No. So you just end like 2 plus 2 like that. So that's about number one. So number two now, they are saying it was like that. So when you put f of of 2, all right, when you put f of 2 there inside, that will be now you put wherever there's x, you put what? 2. Okay, so when you put 2 there, that will be 2 root of plus 7 like that, then plus 2 like that. Okay, so that will be what? 9 inside root 2, then plus 2. Okay, so that will give you what is root of 9? That will be 3, then 3 plus 2, that will be 5. So that is about that one. Also solve other things, and it's just the same thing. Like you go and you press wherever there's x, what they have put you inside the function. Okay, so we are dealing as x changes anything, so we are only interested where x lies. So now for this one, for the third one, we have, okay, so f of x we know is what? Is the root of x plus 7, then plus 2. So giving now, putting now, wherever you substitute whatever is inside, so put x, wherever there's x there, I'll put x minus 7. All right. So plus 7 plus 2. So then inside there, that will be x minus x plus 7, right? Plus 2 outside there. So this will cancel, right? That will be just root x plus 2. Can we go anywhere? No. So the answer will be just root x plus 2. Then you are done there. So we are done with the first one. That's what you do. You can pause if you are told you are not clear. So you pause the video and also solve those things. Okay. So the other thing that we can do is we'll say we are done with this one now. Let's go to number 2. Okay. Okay. So we are done with the question 1. Let's go to question 2, which is B. So now we have been given g as t is the function of 3, all right, 3 t squared, then minus 4, okay, close like that, then t squared like that. So starting with number 1 there, okay, they are given to say g of t. So wherever there's g, t will put 2. So that will be 3, okay, okay. So that will be 2 there squared minus 4, all right, over, that will be 2 squared like that. So wherever there's x, you put, wherever there's t, you put 2. So that will be 3 times 9 minus 4 over, that is 4 down there. All right. So this gives us what? What is 9 times that? So we have 9 times 9 is 18 plus 9 times 9 again, which is just plus 9. All right. So you add there, then you get what? That will be um that will be 17. So you put 7 there. Okay. Then plus that, that will be 27 just. So in short, that is it, 27. Okay, so 27, we say 27 minus 4 over 4. This will be 4 times minus 27 minus 4, that will be 23 over 4. So you can write it in proper fraction, but I'll leave at this point. So that was the answer that you are supposed to write. Okay. Okay, so let's go now to a next way. In fact, I was supposed just to write that one. So we'll say now this was what? G of t, all right, is equal to the same function there, 3t squared minus 4, all right, then t squared. So now they are saying now g of 0. So wherever there is z, whenever there's t, put 0. So that will be t0 squared minus 4 over 0. You see? 0 squared. So this will be undefined. Okay. We don't want a situation whereby, so this will be negative 4 there, then over this will be just a 0, then over 0. So this is undefined, by the way. Okay. So we don't want a situation whereby 0 can be a denominator. So we don't have, this is case, it's undefined, it is undiscarded, it's just discarded. So we don't have such in mathematics. So you just leave like that, then you write undefined or discarded, then you forget. So that's about the first one. So let's go to a second one whereby they have put now um so I'll just go substitute directly. I'll put negative t there. All right, so whatever there's t, I'll put negative t. So I'll put negative t there, all right? Then it's squared, then minus 4 over the same t there, all right? Wherever there's t, I'm putting t, so I'll put negative t there, then squared like that. So that would be now positive, just t, so that would be 3t squared, then minus 4 over. That will be again, it's an even, the power is an even, so it still come back, you multiply negative t times negative t, positive positive, so that will be positive t times t, that will be just t squared. So that is the answer. Okay. So this one they are saying now we just compute the same thing. So now here what we do is you always just go and replace the value wherever there's x in that function. All right. So what we do is for the first one, we'll go and substitute there. All right. So there we have um negative 1 negative open bracket, we have what? We have x. So now in the case of x, I'm solving this one. In the case of x, I'll just put negative 2 there, then minus 1 open bracket, then squared like that. So it will be ranging. This is not your duty to do anything there, so you just leave that. Okay, then 3 also, you are not substituting anything. All right, so it will just be 0. Okay, then here you put negative 2 there, wherever there's x, then minus 2 there. Okay, so you end there. So we can just simplify all these conditions, you just leave them like that. Okay, so you leave the conditions like that. So I can still simplify. Let me simplify these ones which are here. So they are inside, that's negative 2. Negative 2 squared, that will be negative 3 inside when you add, but negative 3 squared, that will be what? So half 1 minus open bracket, that would be just negative 3, all right, squared. So that would be 9, right? 9, which is the 9, 1 minus 9, which is the negative 8, like that. So there, all right. So we'll have, here we'll have negative 8, okay. So here then you just leave this is constant, then here you put negative. So this is the negative 4 inside there. So how do we like this? This is same as 4 times root negative 1, like that. So what you do, negative 1, when you see I like that imaginary, this is equal to negative 1 root there. So wherever there's that, I'll put that. So I'll put, what is the root of 4 now? That will be 2. So plus this one, now you are multiplying, that will be just I. Okay, so this will be 2I if you want to write like that. Okay. Okay, so you have simplified like that. Then these conditions, you leave them like that. So this means that if you were to plot this, um, these are now your function. Y is equals to this, y is equals to this. Then you start at the point where x, at this point you start. All these are conditions that will tell you where you should start graphing your function. Okay, hope that is clear. Hope that is clear. So we are not talking about graphing, but we are just simplifying these ones where possible. We simplify. So for this one, it's still the same case. You put 7 whenever there's that. So when you put 7 there, all right, when you put 7 there, that will be just 1, all right, minus. So 7 minus that, that will be now 6. 6 squared, that will be 36, right? Like that. So then that will be negative 35. For this one, for this part. Okay, then this part you just leave it like that. Then for this one you put again 7 there, that will be 5, so it will be just root 5. If you want, you just leave it like that. Then you put those conditions to say x and also negative 2 x 2. So x, so you'll just leave these conditions, then you'll be very okay with that. Okay, still the same thing here. When you have this and we are taught to compute, I'll solve this one and also this one. This one, they made an error there. We had only the function of x learning as hx. So what we do here for this one, you just compute like that. All right. So it's function of h. So I'll put 2 there, negative 2 by the way. Then is equal to absolute value of 5. Whenever there's, we'll put negative 2 there. Then minus 1. Then absolute plus 3 like that. So absolute, this inside there, it will be what? Negative 10 minus 1. Okay. Then absolute plus 3. All right. So there, then that will be absolute negative 11, then absolute plus 3. So this absolute simply means should give you a bit of positive. So there are two numbers, positive and negative, but consider positive. So that will be just 11. All right, then plus 3. Okay. So absolute value, we said in the previous lesson to say it's just number on the number line. I mean a value on the number line or just a distance. So it can be positive or negative. All right. So that's the reason why I've just brought it is now negative inside. Now I'm reporting as what? Positive. So then that will be 14. So that's about for 0. You also put 0 wherever there's 0. You put 0 there. That will be negative 1. So negative 1 in the absolute, you just report as 1, which is z plus 3. So they give you 4 like that. Then for this one, there was an error. But for this one, you just put 6 there. Again, it will be what? 1. 1 in the absolute, that will be still what? 1. So 1 plus 3, that will be what? 4. I'm sure two answers will give the same 4 and also this one and also this one. They'll give 4. I've seen something like that. So that's how you can solve those questions. So let's go find the value of x such that f of x is equal to 0. So wherever there's f of x, you put what? You put 0. All right. So that's the meaning there. So 2x minus 1. So wherever there's f of x, you put 0. So that would be 3x plus 8, all right, over 2x minus 1. So you cross multiply that to give you what is 0. So we have 3x plus 8 is equals to 0. So grouping the right terms, that would be 3x is equals to 8 negative. Then you divide throughout, that would be x is equals to negative 8 over 3. So you are done there. So for this one, we are done. Let's go to B. So B, we put 0 there. Whenever we put 0 there, so that would be 0 is equal to x squared minus 8x plus 15. All right. So from there, then what you're going to do is, it's more like I'm writing x squared minus 8x plus 15. Okay. So that is it. Then we are now going to look at the sum and also the factors. So what are the factor and the sum? So numbers that we can multiply to get 15, and when we add, we get negative. So I guess those numbers are negative 3 and also negative 5. So when you add these, they'll give you negative 8. So I'm replacing there. So that would be x squared. Ah, okay. So what you're going to do, just replace the same thing which is there. So I'll say that will be negative 3x, then negative 5x. I've replaced nothing, like I've changed nothing. This value is also giving me negative 8, so is equal to the sum, then plus 15 is equals to 0. So what is common there is x, then we remain with the 3. Then what is common there is negative 5, all right, open bracket, that will be x, then minus 3 there as well, then is equals to 0. So x minus 5, x minus 3, then is equals to 0. So you can solve now this one. X is equals to that 5, x is equals to what? 3, like that. Okay. So that is it. Even this one, you can still do the same. Let's go and do this one. Okay. So solve the C. Okay, so that will be, so that will be now negative x, like that. So you put 0 wherever there is f of x, and that will be x cubed minus x. All right. So what we can do here, I can write as x power 3, like that, by minus x is equals to 0. Then I can factor out what is common is x. All right. So if I don't want, I can also take x to the other side, but I'll say x minus, like that. Then I'll have x is squared, then minus 1 is equals to 0. So you can see this x is equals to 0. So I already have x is equals to 0. Then this is different of 2 square. So I'll have x minus 1, all right, x plus 1, all right. So it's equals to 0. So I'm solving this part. So now this will be x is equals to negative 1, then again x is equals to what? uh 1, then again x is equals to 0 finally. So in general, this we have this one also, we solve this one, we solve this one to get this and this, then plus this, which is now 0. So these are the answers you needed to write. Just the same case here, all right. Okay, so the here you put 0 for this one, then is equal to 12. This we multiply throughout, that will be now 0, right? So it will be 0 is equal to 12 minus x squared. So from there, then what you do is you group the right term. So this will come this side. So that will be x squared, all right, is equal to 12. Okay. So you, if at all is possible, then that will be just root 12. So that marks the end of that question. Let's look at the other one. So show that f and g are inverse of each other. So for showing that a function is an inverse of each other, there are two conditions, by the way. So you can use that one we used secondary level, whereby you just make y the subject, then you make x, you make x the subject of the formula later, then you show the inverse. All right. So but at this point, we'll be saying when you compose those two functions, all right, they should give you x. Again, when you compose the other way around, all right, they should give you x. All right. So that's the meaning. So you choose which one do you want, but this one is the one we normally use here. Okay. So if inverse of each other. So that is what will be happening if they are inverse of each other. Okay, you compute the other one, then you make the other one as well. So that's what we'll be doing. So you choose. Let me use for these two first. I use for the one at secondary level. So you say that will be now y is equal to x. X is equal to x is equal to x is equal to, you say like that, then you make x the subject of the formula. How do you make the x the subject of the formula? You do this, you say you multiply like that, so that would be x cubed is equal to 80 y like that. Okay, so you do this, you do this. Okay, so that would be x is equal to 3 root of 8y. So you say therefore, okay, the inverse of this guy, all right, is equal to 3 root, then you put x wherever there's y, so you see that this is equal to that. Okay, so that's one way you can show it. Again, when you do the same thing again, it will take you back to this one. So but this point, I want to solve this one, then I'm sure time is going, then we'll use that condition to say if they are inverse of each other, then the composite function of each other, then it should be equal to x. So that's the one I'll use. So I'll say if the function are inverse of each other, f g of x is equal to x, and g f of x, okay, is equal to what? X. So let's do that. I'll get this one, okay, which is f, and you also replace this one. So I'll satisfy this in condition here. So I'll say if they are inverse of each other, I'll get this one and solve this one. So meaning that g is now on the middle. So I'll come bring g and put wherever there's x. So I'll say f of g of x is equal to, wherever there's x, you put g of x. So I'll have g of x there. All right. So I have x to the power 3, right? But I'm replacing now, whenever there's x, I'm putting that function. So I'm putting this function. So meaning that this is, you know what, 8, 3 there, x is same as 8x to the power 1 over 3 like that. Okay, that's what I would do there. So I'll say, um, I'll say okay, so I'll put wherever there's x, so I'll bring that one and put where there's x there. All right, or I can write in this form. So I can write it as 8x 1 to the power 3. Okay, this is just the power of that. Then now we have again to the power what? 3. Have you seen that this and this will cancel, right? Then, all right, then what will happen is that we have 8 there, right? Anyway, you are not satisfied. Let me do it again. Let me not confuse someone there. So we'll work it out and we'll say, we'll follow this condition, this one, to say f, no, to say f g of x like that should be equal to x. Let's do it. So whenever there's f of x, we'll put g of x. So we'll say f of x we know is f of x we know is what? Whenever there's x, so we are putting what? That guy. So we have root 3, okay? Okay. Then to the power 3, this 3 here that we can see there. Then over 8 like that. Okay. So what you are going to do is, we'll say, you see, so how are we going to achieve this? So what we do is, we'll go inside there, all right? We'll go inside there and also do what is supposed to be done. So you are going to realize that this 3 here, so that one inside there, I can write it as 8x to the power 1 over 3. Remember, there's power 3 again, then over 8. Okay, so this and this can go. That will be now 8x over 8. And 8 divided by 8, that will give us x. So condition satisfied. You see? So that's what we'll do also for the other way around. We'll say, we'll now compute g f of x. So whenever there's g of x function and the x is there, we'll put f, right, as a function. So what you're going to do here, we'll get g function, so it's there. So it has root 3 like that. Then inside there's x. So whenever there's x, put that function. So that will be x to the power 3 over 8 like that. Okay. So that will be now, this and this can go, you can see. So that will be now 3 root x to the power 3 like that. And this is just same as x to the power 1 over 3, this 3 there, then the power 3 again, this power here, and which will cancel, then it will give us x. So that's what you can do, and you can try this one and also this one. Again, try this one and also this one are very simple, just go direct, it will be giving you 0. The same thing, very fast. This one is very simple, and this one, but for this one you still have a bit of calculation, but it's not that difficult as well. Try it out using these conditions, you'll see that they are coming out the same way. All right, so this marks the end. Thank you very much for watching. Subscribe so that you can access more of this time.